In this section on basic aerodynamics, we'll briefly discuss the four forces, aerodynamics of a wing, center of gravity, and three-axis movement. The four forces include lift, weight, thrust, and drag. Lift acts upwards. Weight acts downwards, opposing lift. Thrust pulls forward, and drag acts in a rearward direction, opposing thrust. When the aircraft is in straight and level flight, at a constant airspeed, lift equals weight and thrust equals drag. Let's look at each force separately. Lift is an upward force created by the movement of an airfoil through the air. An airfoil is more commonly called a wing. Bernoulli's principle says that as the velocity of a fluid increases, its pressure decreases. Well, air is a fluid, and the curvature of the airfoil forces the air above it to flow more quickly than the air below it. The lower pressure above and the higher pressure below cause the airfoil to rise. The remainder of lift is created when air strikes the bottom of the airfoil and is deflected downwards. This creates an equal and opposite reaction that pushes the airfoil upwards. Remember, the rotor blade on a helicopter is a rotating airfoil, and it generates lift just like an airplane wing. Weight is the force exerted by the Earth's gravity. It acts vertically toward the center of the Earth and opposes lift. Thrust moves the aircraft forward through the air. In an airplane, the propeller supplies thrust. In a helicopter, the main rotor provides thrust. In fact, helicopters are unique in this respect. They can direct their thrust forward, aft, or sideways by tilting the main rotor. In practical terms, there really is no distinction between lift and thrust in a helicopter. The main rotor blades produce both. Thrust is simply that part of vertical lift that's been redirected into horizontal lift. Drag is the force that retards the movement of an aircraft through the air and opposes thrust. There are two types of drag. Parasite drag is the portion of total drag caused by form resistance and skin friction. Parasite drag increases as airspeed increases. Induced drag is the part of total drag that results from developing lift. As airspeed increases, induced drag decreases. We can see the relationship between drag and speed in this graph called the drag-speed chart. You can see that as airspeed increases, parasite drag increases and induced drag decreases. Where these drag coefficients cross at point B, total drag is lowest. If we were to drop down here to our speed axis, we would find the maximum glide range airspeed. And this is called best glide speed. This is the speed at which the helicopter will travel the maximum horizontal distance per foot of altitude lost. Let's look at the parts of a wing now. As the wing moves through the air, the oncoming air will split around the wing over the top and through the bottom around the leading edge. The airflow on top and on bottom meet again at the trailing edge. The chord line is an imaginary line that runs from the leading edge to the trailing edge. Relative wind is the direction of airflow with respect to the wing. It's created by the motion of an airfoil through the air, by the motion of air past an airfoil, or by a combination of the two. For a helicopter, the relative wind is the flow of air with respect to the rotor blades. The relative wind is parallel to the flight path, but moves in the opposite direction. Relative wind may be affected by several factors, including the rotation of the rotor blades, horizontal movement of the helicopter itself, or the flapping of the rotor blades. Also, wind speed and direction. The angle between the chord line and the relative wind is the angle of attack. Don't confuse angle of attack with pitch angle of the rotor blades. Pitch angle is the angle of the blades relative to the helicopter itself. The angle of attack is the angle of the blades relative to the oncoming wind. As the angle of attack increases, lift increases. As the angle of attack decreases, lift decreases. So in a nutshell, increasing pitch angle increases angle of attack, which in turn increases lift. Decreasing pitch angle does the opposite. Remember, As lift increases, induced drag increases and will tend to slow down the rotor blades. Additional power will be required